of the most fascinating discoveries in modern science is that bulk materials behave completely different from their nano-sized counterpart. Now, when I say nano-sized, I'm talking about dimensions 1,000 times smaller than a human hair. For example, bulk gold, which we all know and love to wear, is a nice shiny gold color. But nano-sized gold actually appears red, even though they're the exact same atoms. In my lab, we use another benefit of nano-sized material, and that's its size compatibility with biological components like cells or viruses. Speaking of viruses, I'm sure we've all seen or used a COVID test strip. You swab your nose, mix it in solution, and apply it to the test. Well, what's actually happening are those viruses are splitting open, and the internal proteins are flowing through and getting bound by these unique capture points on the test line. Now, the downsides to this are that one capture point can only bind one internal protein at a time. So if someone's early in their infection, they don't have a whole lot of the virus, but still enough to spread to others, there may not be enough to give a positive signal. Another downside are that these internal proteins change when there's a new variant, which we know happens quite frequently. So they're no longer a perfect match for the capture point, again giving us false negatives. These false negatives are what contributed to millions of lives lost during COVID. So that's where my work comes in. In my lab, we develop polymer nanorods that are actually able to capture sugar. Okay, but what does sugar have to do with this? Well, the COVID virus is actually covered in sugar on all sides, all around. That's what it uses to escape our immune system, but we can use it as the detection point. The neat thing about these nanorods is that they're also reusable because we can capture the sugar and therefore the virus at a high pH and release it at a low pH. Making these nanorods is a lot like cooking. We combine certain ingredients, which are chemicals, at the right ratio to get our perfect recipe. And what we're left with are these nanorods that can capture multiple whole viruses at a time instead of just one internal protein. So we get this amplification effect, and we're able to get a positive signal sooner than previous methods. Also, the sugar around the virus doesn't change when there's a variant, so our method would work for any variant. So all in all, my research combines chemistry, nanotechnology, and engineering to develop smarter virus detection tools so we can diagnose people earlier, stop that spread, and save lives. Thank you.